When you're measuring the gradient of a line, you're really just looking at the steepness of the slope. So we calculate it by saying it's the rise over the run, and this is a ratio or a proportion. And we've got a formula here that can help us do it. If you've got 2 points, for example, here I've got 2 points. If I want to find the gradient of the line or the interval that joins those 2 points, then I can subtract one of the y's from the other over subtracting one of the x's from the other. Now the only thing to make sure of here is whichever y value you start with, you need to start with its partner, its matching x value, on the bottom. Now what do I mean by this? Well, let's have a go at doing this 2 different ways. If we said that this was x1, y1, and this is x2, y2, you'll see what happens here, and that it actually doesn't matter which way you label these, but it's good to know that it won't matter. Because if we do the y2s first and say we've got 1 minus 4 on the top, and then x2, that's minus 2 minus 3 on the bottom, then we'll get minus 3 up here, and we'll get minus 5 down there, but we know that a negative divided by a negative is a positive anyway, so we're going to get 3/5. Now, if we'd labelled them around the other way, with these being the 2's and these ones being the 1's, then as we started with our y2 here, we would have said 4 minus 1 over 3 minus 2. And that gives us a 3 on the top and 3 plus 2, which is 5 on the bottom, which is the exact same answer. So don't get too bogged down with which is the 2's and which are the 1's. The reason it doesn't matter is because if you end up with both numbers being positive, then if you'd done it the other way around, you would have had both numbers being negative. They cancel out and both numbers are positive anyway. Or in a different sort of example where the top or the bottom of the fraction was negative, just one of them, well, think what happens if you have a negative number on the top but a positive number on the bottom. That's exactly the same as saying, say, negative 3/5, okay? And it's also exactly the same as saying 3 over minus 5. So whether the negative popped up on the top or the bottom, if only one of them is negative, the answer will be negative, and it won't matter which one had the negative in it. Now, it's important that you understand that what we're finding here is the rise over the run, and in case we forget this formula or we're just not quite sure how to use it, it's really important to understand where it comes from. If we just drop a line straight down from one point and straight across from the other so that they meet at right angles, we've got a right angle triangle now. And you can literally just see the height of the rise and the length of the run and make your fraction that way. The disadvantage would be that you've got to take the time to graph this thing. So in an exam, it'd probably be quicker just to use this formula, but it's always good to check that something makes sense. In a rough sketch, it might be something you have anyway. So here we can see that the y value of this point is 4, and at this point is 1. So between 4 and 1, and that's all we're really doing when we're subtracting one from the other. We're saying, how long is that? Well, from 4 down to 1, we can see it's 3. And going across here, we've got 3 plus 2. We can see that that's 5. So we get our gradient of 3 over 5 that way. Now, if you're working this way, just looking at the chart and thinking it through, you just need to be careful that when you have gradients that go the other way, you need to recognise that they're negative. Now, the way I remember this is I actually think of reading a graph from left to right. So as you move your eye across from left to right, just as you read a word from left to right, imagine yourself in a car or maybe running, going up the hill if you're going this way, or going down the hill if you've got one that looks like this. Now, if you're going down the hill as you read left to right, then this is going to be a negative gradient. And negative gradients always go this way, and positive gradients always go upwards as you read from left to right. So that way, if you've got one like this and you've dropped a line down, in one like this, let's just say we had these points already labelled, and we knew some intercepts here, we've got 4 and we've got 7, simplest way to find this one, rather than using that formula, would be just to say, hey, I've already got a right angle triangle here, which is so easy. I know that length, 4, and I know this length, 7. But don't be too quick to jump and say, hey, the gradient's 4/7. It won't be 4/7, it will be negative 4/7 because it's going this way. All right, so before you analyse anything with gradient, always just check, is it positive or is it negative? Now, don't forget that because this is a ratio of rise to run, you can have a nice, simple right-angled triangle like this. You've got your rise and you've got your run, and you can see the lengths of these lines here. But you should understand that you could drop down any line that goes down and then straight across and meets at right angles and make a really tiny triangle, or you could drop a line down a long way and come across a long way to make a really large triangle. But it doesn't matter which triangle you make, as long as it has a right angle and it's coming down from this line and then straight across to that line with the right angle over here. All of these triangles will be similar triangles, which means they're in the exact same proportion with their sides. So if you take one side and divide it by the other, you'll get the exact same answer. The other trick you need to make sure you don't fall for is spotting negative numbers like this and automatically assuming that that goes into your answer for your gradient. Here we can quite clearly see that this is a positive gradient because it's going up as we read the graph from left to right. So here, there's no need to drop down any of these boxes and make triangles this way when you've got one absolutely looking at you right there. And if this is 3, then we know that the rise here is 3. And then if this is -4, it means it's 4 units across from the origin. So this length is 4. So our gradient is simply 3 over 4. And the fact that this is a negative is completely irrelevant. You're looking at what this length is. Now, 2 other lines that you should understand the gradient of are horizontal lines and vertical lines. Now, horizontal lines have a gradient of 0 because their rise is 0. If you take this and try and drop a line down and then straight across to meet the line, of course you can't drop a line down. That rise is nothing. It's a completely flat triangle. So with a 0 on the top of the fraction, we just say that the gradient is 0. But vertical lines, if you try and drop a line down here and then go across to meet the line, of course you can't go across. So they have 0 for their run. And because they have a run of 0, you can't have 0 on the bottom of a fraction. So we don't say that they've got a 0 gradient, we say that their gradient is undefined.